Hi, my name is Abraham Pabati, and I'm the team lead for Team Skynet in Chicago. And we built a app to order food supplies for restaurant owners. It all started when one of our large clients in Chicago, a food distribution company which supplies food to thousands of restaurants, came to us and said if we can make sense out of their e-commerce clickstream data. And they wanted to personalize their customer experience using the data. And the timing was perfect because the Slalom AI Hackathon was just getting started. So we said we'll use that data to figure out what we can find out and help them personalize the customer experience. And in fact, we went a step ahead and asked them to give us some historical customer purchase data, using which we could build some models to predict customer purchases in the future. And we went even a step ahead and said, we'll build a mobile app where the restaurant owners can take a picture of a food item or a recipe item and order the ingredients automatically using that app.
Analyzing the clickstream data that we had for this client, for this AI hackathon, was a lot harder than we originally anticipated. First off, it was quite challenging to get this data into Slalom's environment from the client's environment because we had to go through multiple approval processes, which took longer than we anticipated. But luckily, we were able to use an AWS EC2 instance to transfer data from one S3 bucket to another into our environment. Secondly, there were about 700 files at about half a gig each that we had to load. And again, this was extremely challenging. And on top of that, we had to build multiple staging tables in between to be able to write queries to explore the data that we were not very familiar with. And this was especially challenging because there were some fields that we didn't know what they actually represent, and there were sometimes 50,000 or more characters in length. But through a lot of hard work, determination, and long nights, our talented team was able to parse through this data set and build it in a way that was efficient going into the model to be able to build a solution that we think is going to be highly efficient and valuable for our client.
Oh, hello. I didn't see you there. I was just doing some exploratory data analysis for our Slalom Hackathon. Here's some preliminary findings that I found about our customer. First of all, the customer's company base is well distributed throughout the country. Web traffic patterns follow state populations almost identically. Further, this customer knows the website well. French fries are in 70% of customer shopping carts. However, they're almost never searched for. Lastly, customers typically place orders on Monday between 12 and 3. Likely replenishing depleted inventory over the weekend.
Modeling the data wasn't easy either. We weren't entirely sure what type of models we were building, but we thought we wanted to do something predictive that used machine learning. We started by trying to format the data for logistic regression and found that using categorical variables to predict more categorical variables or outcomes was not entirely effective. We switched then to a k-means clustering algorithm. We started that based on historic orders and found that if we just use historic orders for the input of the k-means clustering algorithm, then we just ended up with segments based on menu type, which wasn't entirely helpful. When the clickstream data was finally formatted, after weeks of parsing through it, we found that if we had the duration of the time that people spent on each page, we found 4 distinct types of customers. We had the second guessers, the lookin' not cookin', the express checkout please, and the regulars. Those 4 groups were based on how long they spent on either adding the products to the cart page, reviewing their orders, editing their orders, searching the products, general search time, or when they submitted the orders. From that, we realized that with more data, we will be able to further segment the customers and provide a more enhanced and personalized customer experience on our app. We then did a market basket analysis based on historic orders and built rules of about 1,800 rules that will say if a customer buys X, they will most likely then also buy Y. It's dynamic enough that if 2 items are in a cart, then it will change the output of what will most likely be the next item added. We use that market analysis to provide the input for the recommendation engine on our app.
Yeah, and with all the modeling built, we wanted to bring that capability to a very user-friendly mobile interface. And so we got cracking to develop a web app. And so here is a brief demonstration of that. And so if you notice here, this is just really simple format. We don't want to confuse the customer too much, but let me just show you just what the user experience could look like. And so let's say I'm an independent restaurant owner and I want to order something that I just saw in my inventory. So I'm going to click order, and I'm going to first upload a picture. Upload it. Perfect. Now, with this picture uploaded, I'm going to scroll down, and you notice there was a feature that was recognized beforehand, but let's say you just want to recognize the picture. It instantly looks at it and says, oh, this is a citrus fruit within the fruit category, and this helps better understand where the user can best purchase these items, or what keywords to search when looking for this item. Because let's say this wasn't an orange, for example, it was a random fruit that this person has never seen before, and instead of spending minutes searching for it online to figure out what kind of fruit it is and how to order it, it can automatically flow into the exact plain English category. And then further, it can show just a market basket analysis of like, oh, we noticed you took a picture of a citrus fruit. You may also like eggs, so on and so forth, if this is a breakfast restaurant owner, for example. And then it can also show, depending on how detailed you want to get, the confidence interval with which the next purchase will likely be. And so with all this in mind, we want to shave those hours and minutes into seconds for the end user, so that when they're ordering their supplies, it's not just about ordering supplies for the sake of ordering supplies, it's about engaging with their clients and their customers as best as possible. And we want to get them there.